Lesson 7, circular interpolation using G2 and G3. We're going to be using discriminator software here to write this program, and we're going to get started with that. And so as we take a look at this, we're going to start off by taking a look at our print. Basically, we're going to set up our spindle speed at 3056. Here's our calculation for that. We're going to start off with a percent sign, and we'll start off with program number 012. And as we look at this part, we're going to see that our program 0 is set up in the top right-hand corner, and our cutter is a 1/2 inch end mill. We're going to calculate the distance from 0 to the center of the tool, and we'll write the program from the center point of the tool to the center point, and then we'll go counterclockwise, which would be G3, linear G1, counterclockwise G3, linear G1, counterclockwise G3, linear G1. And we can program these with R or I and J. R is much faster as we go through and we work this. And so here we are, line number 1, we're going to go with percent sign. And so we'll say percent, enter. And line number 1 should be by itself for the most part. Next line, we'll say line number 2 will be G20, telling it that we want to work in inch mode. Next line will be G0, G17, G40, G49, G80, and G90. And this is our safety line. What that does is it cancels all the can cycles that we were running, sets the XY plane, and it gets rid of cutter compensation, drilling can cycles, and it also gets rid of the, and then I should have G40 in here, so it goes G17, G40. There it is. Cutter compensation, tool length compensation, and can drilling cycles. Next line will be a tool change. We'll say T4 M6, and that's going to comment out our tool. We're going to be using a 1/2 inch end mill. Then we're going to go to our G54. Our G54 is located right at this point right here. And what we're going to do is we're going to calculate in the x-axis 0.25 over, and in the y-axis 0.25 up. And so we'll say G0, G90, G54, X 0.25, Y 0.25, A0, S 3050, and M3, turn on the spindle. And that will send the tool to this location right here. Next line will be our height offset. So we'll say G43, height offset 4, Z.25. The next line will be Z.2. And then a G1, Z0, feed rate 6.4. We'll then go to X0, feed rate 18. We'll go to X minus 2.5. And then we'll go with our G3. And as we look at our G3, we want to look at the X ending point, which will be 3 plus 0.25, which will be 3.25, and that will be negative. And so we'll go X minus 3.25, and then the Y ending location. The Y ending location will be 0 and minus 0.5. And so our Y ending location will be Y minus 0.5. I is going to be 0. So the distance from the center of the tool to the center of the arc in X does not change. So we'll say I0. And we'll say J is going to change. J is going to be minus 0.75. And so in the x-axis, it's going to change minus 0.75, which would be 0.5 plus 0.25. And since we're going in the negative direction, it will be J minus 0.75. Next line will be linear interpolation, G1, Z minus or Y minus, and the value would be 3 inches minus 0.25, 2.75. Next line would be then a circular arc move. And so we would be going counterclockwise. That would be a G3. So we'll say G3. And then we give the ending location in X, which will be 3 minus 0.25 or 2.75. Excuse me, 3 minus 0.25.
I think is.
I was right. I was right. Thanks. Yeah, and so it should be x2 minus 2.75. Right?
Yes.
And then my y is minus 3.25. And because it's y would be minus 3 and then add the extra 0.25 for the radius of the tool. Good enough. And then I and j, rather than do I and j, we could do an R value. And so we could say R 0.75. And that should be acceptable. We'll find out if the back plot will plot that. And so that's our G3. It's our second G3. And then we'll go to a G1, X minus 1. And then we'll go to our next arc location, which will be our G3. And we're going to say X 0.25. And so that'll be our X location from here to the center of the tool. That's correct. And then we're going to say our Y value will be from here, minus 3, minus 1, minus 2. So our Y value will be minus 2. And our radius will be 1.25. And then our next value will be a G1, Y0. And then another G3. And I think it's just a G1 here, right? Because I've got, let's see, 1, 2, 3. And so here's 1, 2, and 3. And so we can say G1, Y0.
Only I believe for block number 13, when we have the second G3, R in its appanage. The radius is 250 plus 250 radius of the tool.
Right here, 250, 500, right?
No, and the second one, what is the R point? Yep, that's R 0.5, right? But the radius is 0.250. Okay.
Right. And then G1, Y0. And then we're going to go with G0. Z.25, M5, G91, G28, Z0, and we can say M30. And then we can backplot this. We can go through and check it. Here we go. And that looks fine. Okay, so that's how to write the program for are using discriminator software for mill lesson 7. And that completes this recording.